Alright, so today we're solving rational equations. So first thing we have here is just saying that it's a legal move or whatever, that I can square both sides, as long as I square everything on both sides. And then the other thing that we have over here is that 2 squared is 4, and so is the square root of 4 squared. What that just shows us is that when I have a square root sign and a squared, they cancel each other out because they're inverse operations, and so I'm just left with what's left inside of the radical sign, which is what I just said here. Squaring is the opposite of taking a square root. So the first thing that I want to do is get the square root by itself, and then square both sides. Second thing is then just solve an equation like we normally would, either by factoring or by getting my variable by itself. And then the last thing, I always have to check for extraneous solutions here. So here the first thing that I would do is I would get my square root by itself, so I'd add 7 to both sides. So you get the square root of x is equal to 7. The square root's by itself, so I square both sides. So I get x is equal to 49. Again, I want to double check myself, so I take 49, I plug it in for x of my original equation. Square root of 49 is 7. 7 minus 7 is equal to 0, and that's true. Over here I have the square root of 2x minus 3, then plus 3 is equal to 4. So again, get the square root by itself by subtracting 3 to both sides. So I get the square root of 2x minus 3 is equal to 1. Square both sides, so I get 2x minus 3 is equal to 1. Add 3 to both sides and solve it like I normally would. 2x equals 4, divide by 2, divide by 2. So you get x is equal to 2. Again, double check it by plugging it in my equation for x. 2 times 2 is 4. 4 minus 3 is 1. Square root of 1 is 1. So then 1 plus 3 is equal to 4. That's a true statement, so x is equal to 2. So I should circle this one as well. These ones I have to check for extraneous solutions. So again, with this first one, I have the square root of x plus 2. Square root is already by itself, so I square both sides. So I get x plus 2 is equal to x squared. The easiest way to do this is to move my left side over to my right side, because I want to keep my x squared positive. So I minus x and minus 2 over to the other side, and get 0 is equal to x squared minus x minus 2. Then I can factor this into 2 parentheses, different signs, negative 2 and positive 1 is my winning combination. Separate this into 2 equations, x plus 1 equals 0, x minus 2 is equal to 0, and I get x is equal to negative 1 or positive 2. Again, I want to double check these, so I take 2 and I plug it in for both these x's up here, and I want my original equation, so in my original equation I didn't square anything yet. So when I plug this in, plug in a 2 for both of these x's. 2 plus 2 is 4, the square root of 4 is 2, 2 is equal to 2, so 2 works. Then I want to do the same thing with negative 1. Negative 1 plus 2 is 1, square root of 1 is 1, or I should probably change these to negative 1s. So when I plug that in, again, negative 1 plus 2 is 1, square root of 1 is 1. 1 is equal to negative 1. That's not true. And so negative 1 is my extraneous solution. Over here I have the square root of x plus 13, so I'm going to minus 13. And get the square root of x is equal to negative 13. Square both sides. X is equal to 169. Double check my answer by plugging it back into my original equation. A square root of 169 is 13. 13 plus 13 is 26. 26 is not equal to 0, so this is an extraneous solution, so that means that I have no solution. The last thing here was our geometric mean. Again, just a different type of average. I multiply my numbers together and then take the root of however many numbers I have. So here I'm just using two numbers. So I'm going to take the second root, which is the same thing as a square root. So I'm multiplying together, take the square root, and that'll give me my geometric mean. So when I do this, find the geometric mean of 70 and 29. So I do 70 times 29. Oops, what did that do? There you go. And that gives me the square root of 2030, which is equal to about 45.1. Oops, it's supposed to be 1. That's sloppy, I don't like that. There we go, 45.1. Then this bottom one, I want to find the other number when the geometric mean is 16 and one of the numbers is 4. So again, I know one of the numbers is 4, I don't know the other one, and I know the geometric mean is 16. So again, just like we did before, square root's by itself, so I square both sides. I get 4x is equal to, I think it's 256. Then I divide both sides by 4, and x is equal to 64.